My name is Celia Cano. I'm here with Marine Technology TV, and I'm here today with James Thompson and Hobie Boeschenstein. Thank you guys for being here today.
Thank you so much
Thanks
for
for
having
having us.
us.
Just to get us started, if you could each share, a brief introduction, including your role within this project to map hypoxic zones in the Gulf of Mexico.
I'll jump in to start. My name's Hobie Boeschenstein, Director of Operations and Business Development at SeaTrac. So the team at SeaTrac provided the uncrewed surface vehicles that were used for this project, and we worked closely with the team at USM to configure the boats with the appropriate sensor packages, um, to get them set up with the profiling instrument and winch to be able to go and collect the data that was needed, and then sort of just work to support them and make sure we did whatever we could to help them be successful.
Yeah, and I'll dive in on top of that. So I'm James Thompson at USM. And so basically what we were uh, trying to accomplish here is for NOAA's fisheries department, they do sort of a ground truth experiment every year to sort of collect data on site down here south of Louisiana to sort of see how hypoxia impacts the Gulf and the next year's fisheries populations. And so we approached that from an uncrewed vehicle standpoint. And uh, you know, many years prior, it's been a very labor intensive crewed operation with a large research vessel. And we think we can sort of modernize that with the tools that are available now, like the SeaTracs, and that gives us sort of an ability to really integrate academia into the science and government side of things, and using all these new modern commercial technologies.
Thank you for that. So I want to dive a little bit into the research itself. So what was kind of inspiration is not the right word, but the motivation behind this research initially? I know this has been an ongoing project. And then how did this collaboration with SeaTrac come to be?
Yeah, so the motivation is obviously improving science and reducing the cost of it, right? That's kind of always what science boils down to, is how much more bang for the buck can you get? And so with that motivation in mind, we were looking for a platform that was reliable, obviously low impact to the environment, and flexible enough that we could collect all of this data and look at it in real time, speed up the science, if you will. Um, so sort of a natural choice there is moving to this unmanned system where it has so many different ways to operate different sensors and communicate that data back to us, with satellite links and cell links and you know um, things that just weren't available, um, and doing it where we don't have to put people out there in hurricane season. That's a big consideration because over many years of studying this stuff, obviously there's always been years where it had to either get shifted in time, or um, a couple of years where it didn't even get done because it just you missed the window with a research vessel, and that's it for the year kind of thing. These are much more flexible.
And I guess I'll layer on quickly. I think James covered sort of most of the key points. But from the SeaTrac side, we build these uncrewed surface vehicles as a platform for maritime data collection. It's effectively a tool for scientists like James, as well as sort of commercial and defense customers to go out, collect the data that they need without having to put, people out on the ocean, which allows us to help our customers keep their costs down, lower risk, and improve the sustainability of efforts to go out and collect data. And hopefully, in doing so, enables new ways of collecting data. So maybe you can only send a ship out for 1 week a year due to cost restrictions and sort of practical limitations. But a platform like ours, you could put it out and run it for the whole year, collect different time series of data, or just find different ways of approaching the data collection that is not practical with some of the traditional methods. And so we're here to support our customers and allow them to go out and collect the data that they're going after.
Absolutely. I mean, we're seeing a lot more of this kind of uncrewed, unmanned research going on. I mean, especially like you said, James, in, periods and seasons when it's just too unsafe to put people out there. So it's great to see this kind of collaboration. I want to look a little bit at the research itself. So I know that this is the second phase of the larger project. And so I was wondering if you could just give a brief overview of what you've done already, both, what's been done with the USV, if anything, and what kind of findings were there in the first phase.
Yeah, absolutely. So we started out just sort of proof of concept that these vehicles and the sensors that we could equip these vehicles could actually handle the science that we need to know. And so that was the first effort, and that was we learned a lot of you know what we needed to tweak to make that function. Obviously, it's a steep learning curve as fast as this industry is moving, um, and we did it, I think, much better than we expected, and I think much better than NOAA expected. And so then the logical progression of that was to move to sort of a longer full duration survey where we're actually looking at the difference between um, more complicated setups of sensors. And so 2024 was very much like a proving that you could run multiple vehicles at the same time, and what were the best configurations to do that in. And so we had two SeaTracs equipped slightly differently, and that proved extremely successful. They're solar powered, so that was a huge advantage. And what we learned was that the vehicle could produce all this power, but we weren't taking full advantage of that. And so this past 2025 season, we switched over to where all of the sensors could be recharged or powered by the vehicle. And that was a huge game changer as far as how much data we could collect. We didn't have to limit ourselves based on the power available in the sensors. We could collect more and more data, and it actually really showed the advantage of being able to just not just hit like the certain coordinates that we'll hit every year, but also find where that boundary of hypoxia changes, zero in on that by taking additional data samples.
I'll sort of jump on. I probably don't have a lot to add on the science side of things. At SeaTrac, we're focused on making sure our boats are reliable and uh, do what our customers need them to do. And so I'd say we were more heavily involved in the beginning of the project when it was, uh, to do this work, we had to develop a new winch to take the sensor and lower it from the sea, surface to the sea floor. And a very important part of the hypoxia mapping is getting all the way, to within a meter of the sea floor. Otherwise, you'll miss important data. Um, and so a big development effort on our part was, how do we ensure that the sonde gets all the way down there? And so we worked closely with their team to look at some different ways of doing that, and ultimately came up with a system that would uh, use a sort of set of software parameters to detect slack in the line, and basically know that, okay, the sonde is actually on the bottom, can't get any closer than that. And so that was a pretty good development effort for us, making sure that worked in all different sea states. And so we worked a lot more closely with the team at that point, sort of getting the technology ready. But by sort of the phase two, the full phase two, phase three, we were pretty hands off and mostly just standing by to, take calls and support if needed. And I don't recall them actually coming. So it was more us calling them, hey, are you guys all right? Is everything working? Can we get an update? Yeah, we're fine. Don't worry about it. Um, so it was pretty hands off for us by the end, but again, not so focused on the science. That was more the USM guys department.
Yeah, and I'll add on to that. So when we're looking for the largest effect of hypoxia on the fisheries, you're looking at that, layer that's right there near the bottom where all of the, bottom dwelling critters are. And so obviously if they can't swim up and out of that, then it's going to affect their metabolism and productivity. And so that's what really sort of follow on causes an effect in the fisheries chain. And so by being able to get the sensors all the way down there to the bottom and know with certainty that we got them in that bottom layer of water, and then being able to look at that in real time and say, like, yes, we're still detecting low oxygen here. Move further south and see if we can find that edge where, we're back to oxygenated water again. So those being able to sort of adjust the mission on the fly, and know that we're getting the data that's relevant was absolutely critical.
Fantastic. Well, I mean, I'm glad it was successful. I'm sure, it's kind of concerning to not get called at first, but to know that it's a good thing that everything's going well is great. Um, I want to look also really briefly at phase two. So what was different? And again, what results did you walk away with if you're able to share?
Yeah. So I think so basically one of the things we really have been moving towards each time is, improving the integration of sensors, improving that data flow so you're getting, faster turnaround on the actual science value there. And so from, phase one was very much testing that can be done. Phase two was very much improving the way it was done. So that included things like, you know, more rapid turnaround on the data flow side of things, getting that data from the sensor to the boat and from the boat over, satellite to our system so that we could share that with NOAA in real time as we were going. So that was probably the big one. The other big one, I mean, these sensors are all sort of developing at their own pace as well, right? So you have to um, sort of take advantage of that development in addition to the scientific changes and the abilities of the vehicle. And really we found that, like, adding things like higher bandwidth satellite connections like Starlink, for instance, that's huge. And moving forward, that's definitely a huge consideration on all of our projects. It's been an absolute game changer to be able to use the vehicle's Starlink connection. Um, and that allows us to move from a periodic update of data to a literal real-time flow of data from the vehicle. So that was a big step in the way of the science here.
And I'll just sort of throw on there or add on to that quickly. I think one other difference, James, you alluded to it earlier, was that AML Oceanographic, the company that makes the profiling instrument, um, has developed a wireless charging ability for it, which enables it to go out and, traditionally would have to balance. All right, we're going to turn the sonde on, collect the data, pull it off, and then put it back to sleep, which would make it challenging to have to wake it back up or make it sleep too long. And eventually it runs out of battery. And so it sort of limits what you're able to do with it. And so I think from phase two to phase three, I think in phase two, one of the boats had a wireless charging collar on one of the smaller sondes, and then we had another battery operated one. And so by
Yes.
phase three, AML had rolled out this new capability, the Enduro, sort of wireless recharging, and that was integrated on both boats, which meant the USM team didn't have to be on site to swap out the sonde to get a fresh battery sort of halfway through, and really sort of opens up the potential to extend these surveys for much longer durations. And this was still, I think, a week or two of data collection, but you could pretty easily see positioning the boats out there and running the same line over and over, once a week, once a day for the entire summer, the entire year, to just get a fresh sort of new look at the data over a different time period versus saying we're going to do the same week every year and see how that changes. Now it's all right, let's look at it sort of from a fresh perspective there. So
Yeah, absolutely. And I think one of those fresh aspects of that is when you're not constrained by the battery or having to go service the vehicle. That's a huge cost savings because you can, you don't have to have that boat sitting there on standby to take personnel out there. So again, it's a safety issue too. Like, you're removing people from, having to go service a vehicle out at sea, which in itself is, kind of a precarious dance. Um, and, it really, it makes it so that you're so much more flexible with, um, like you said, the way you can collect data, how long you can collect data for. And so we actually, while the mission itself was only, I think, like 6 days of station collecting for the purpose of NOAA, the vehicles were actually out there for, I think, closer to 12 days, collecting additional data to and from that mission. So, um, it's just that's how flexible it is, and we could have stayed in that area and continued to operate, if we just had a lot of other projects going on. And you know, it's those boats are in high demand, so they stay busy.
Great. Well, again, I'm glad to hear everything went well. And it's, it's very exciting to kind of be able to grow on the first part. One of the last things I want to make sure we talk about, because that is kind of, the crux of this research, is about the USV itself. And so if you could talk a little bit about, its specs, and then what makes it fit for this research, including, did you have to add anything to it? And, kind of how did that process go of figuring out how to make the USV the best it could be for this project?
Overview on the platform itself. It's called the SP48, or solar powered 4.8 meters is sort of where the name comes from. So it's about 15 feet long, weighs roughly 650 pounds. It's all solar powered by a large array of panels on deck that charge an internal battery, so it can run 24/7 on missions up to months at a time. It's designed to run both sort of near shore to open ocean, and this mission was a pretty good blend of that. The closer data points I think were about 5 miles offshore, and then it was out to about 40 miles. Um, and so the boat was able to perform both in kind of the closer in measurement stations as well as the further out ones, with multiple redundant communications links on board. And so I don't know if you guys used cell for the in close data stations, but
We
in the
did.
last trial, basically can hand off between cell when it's available, and then having Starlink on board for the true sort of out over the horizon data backhaul is very helpful. Um, but the boat itself is really a platform for data collection. And so kind of, I think one of the reasons the USM guys have latched onto it, and James, correct me if I'm wrong here, was sort of the versatility of the platform. We think of it kind of as a pickup truck where, the platform itself isn't all that useful for anyone. It's really all about the payloads you can put on it and being able to quickly swap those out and put on different either sonar units or water quality sensors or oceanographic sensors. And so we try to make that really easy. And I caught up with James about a week and a half ago, and he was telling me all these things they put on the boat that our team had absolutely no idea about. And so it's designed to give them a tool that they can use for a whole bunch of different projects. Um, Specifically for this one, the big development effort on our side was the winch and being able to support profiling down to the seafloor. Um, and then I think throughout the course of the project, layering on additional communications like the Starlink Mini was kind of the big addition from when we first started this to later in the project, basically just building out additional capabilities to support them and their team.
Yeah, and I'll add on to that. I mean, some of the really great aspects about this vehicle is how flexible it is to integrate new technologies, new sensors. It's so versatile as far as what we can put on it. We tested cameras, we tested some, collision avoidance stuff. We tested a lot of different things while we ran this hypoxia mission. And that just goes to show you, sort of how flexible this boat is. One of the other things that we collected just because we could was acoustic current data. So it basically looking at the different layers in the ocean and which direction and how fast the water is moving the entire time we were collecting all of these samples for NOAA. So it's it is a pickup truck. You can put so many things on there, and with the size of the battery and the ability to generate so much solar power is um, it's a game changer. It makes it super useful for us.
Amazing. Well, it's been great getting to hear about this research. And I'm excited to see what's coming next, both with the data and next steps. But thank you both for being here today in the meantime. And yeah, we can't wait to see what happens next.